So in Python, we said that the first thing to do is import the packages that you want to use. And one of them that we used last week is NumPy. And also, if you want to plot, you import matplotlib.pyplot as you put it as PLT. By this time, you know this one. So we have our packages. And then now you represent the variables for this. So we are going to input this h of n and also x of n. So we shall say that x, let's begin with h of n, the way it was given. Can just say h of n is equal to np. Remember, it is our numpy that we can get. Then we can say array. Yes, the way it has given us. I can press tab. How does it know? 1, 2, 1. Yeah. So np.array. Now for signals, this is very good because it arranges this one as an array. Okay, you can, even if you don't use array, it will work, but always we want to represent that number as an array. Then you get x of n, it will be also np.array. Yes. Then you put brackets, and inside you put big brackets. So this one is represented as vectors. So 1, 2, 3, 1, like that. And then after that, you can say compute hash, the comment, you say compute now, compute the convolution. Yes, so to compute the convolution, you get y of n, which is the output. This is numpy times, now convolve is the function that we have in Python, especially numpy package, that then you can give the impulse sequence and also the input sequence, and then it will compute. And then from here, you can simply print. You can say print the what? y of n. Okay, as simple as that. And then sometimes they ask you to also print the length. Yeah. So this is the length. If you want to know the length, like here we said, these are 7. So you want to know whether you need have the correct length. So as simple as this is enough. And then after this, you can either plot to visualize. So for now, let me run this code and see if we don't have errors. Perfect. You see here, now we have 1, 4, 8, 8, 3, minus 2, minus 1. 1, 4, 8, 8. And this is the answer they had given us. That means our code is correct. And then when you count, you get also 7, the length. But then we also need to know that this is y of n. You can say, and use, these are formatted string. You can say, we want to format the output so that clearly it shows that that is y of n. You can say, this is coding. So you can put a thingy here, okay, in quotes. Then outside, you put the variable here, the one you want, and then it will print. Even here, I'm going to say this is the length of y of n. We can put that and then put a comma here. And you should be able to produce the output, formatted output, yes. So this is y of n given by that, and the length of y of n is 7. As simple as that. So this is our code. This is how you can compute convolution using Python. And then, with that one, you can mute, and then, yeah. So this is it. Any question? If there's no question, then I can plot as well, because we need to visualize this y of n. Okay, so here I can say now the comment using has plot the sequence or plot the output y of n. So to plot that, now you see, after putting a comment, it tells me what to do. Okay, but I can, let me do it myself. So you can plot plt.stem, because now it is a discrete sequence, and then you can put y of n if you want. If we did this, it will work, but normally, if you want, you first do what? Get the n, the samples, using np.arrange, okay, and then you can give either from 0 to the length of y, because now you need to know the length of y, and then in steps of 1. If you want, you can represent it like this. Okay, and then you plot, this is y of n. Remember, it has to be this one. And then here, you can say n and y of n. As simple as that. And then we can plot. See, Python is very easy, as long as you understand the basics. So when you click, yes, perfect. So this is the plot of our sequence. And even in the exam, sometimes you're asked to plot the sequence and you can plot manually. Okay, at 0 sample, we had 1. So this is a 1. Okay, when you put here, it is a 1. At 1, we had a 4, and this is 4. So you continue like that. At 3, you have 8. Okay, at 2, because now you plot from 0, 1, 2. So this is 0, 1, 2, 3, like that. So you plot the values, and it has plotted exactly the same. Then you can do what? You can give labels, X label. You need to know how to label your system. X label is n. These are the samples, the sample positions, and purity dot y label, and this will be, yeah, y of n. You can even say y of n equaling to x of n convolved with, convolved, you can use this, it is a star, convolved, it is the same as multiplication, h of n. Okay, that is, no, this is the title, I think, not label. You can say this is title, because the y label will be purity dot, I think we need to put it up. Some people are not seeing. Okay. So you can say purity dot y label. So y label is y of n. Yeah, or the amplitude. And the title is the convolution of those two. X of n convolved with h of n. And then you can say purity dot legend if you want. And also purity dot. So, but these are for just beautifying the function. Even if you don't put them there, it will work. Let me see, print. Perfect. Perfect. So you can see the labels. This is the title, y of n equaling to x of n convolved with h of n. This is y of n. And these are the values we got, and this is n. So you can plot the sample positions against the values at the end of the day. So this is how we can compute convolution. And I think we are good to go. Okay.